I'd like to welcome you all to the evening session of the Forest Connect webinar series. It's November 2020, and as is usual, we have a guest speaker, and once again we have an outstanding guest speaker. We're joined by Martin Feehan. Martin is a graduate student working with Dr. Paul Curtis, and Martin will tell you his story and how he's been involved with this location of Fort Drum for several years and is still is very knowledgeable about things that are going on up there and has a great presentation about his project. So Martin, I'm going to mute my microphone and turn it over to you. It's all yours. Welcome back.
Thank you, Pete, and good evening to all of you. So I am a PhD candidate, and I'm going to be talking a bit about some of our work up at Fort Drum. And this work really is actually kind of a small fraction of everything we're doing up there. The project has grown to be quite large in scope, and that's really just because of how the different results have led us to other things. So it's one of the incredible things, and I'll talk more about some of the benefits of the site. But Fort Drum allows us to just research a lot of different things and monitor a lot of things in an urban context you just can't do in most sites. I want to alert you all, if you have questions, please put them in the comment section or in the chat section. And then at the end, I will go through all of the chats and we'll take as much time as we need to get through everyone's questions. But I'll get them through all of them there at the end and we'll get started. So tonight I am going to talk about the management of urban and suburban white-tailed deer in Fort Drum and the link between forest regeneration and critical bat habitat. You can see here some of our tagged deer from Fort Drum. This one on the left here browsing right at the tree browse line. And on the right here, one of our housing areas on Fort Drum with lots and lots of deer. All of this work is also done with Paul Curtis, who's the principal investigator on this research and my major advisor. And then Raymond Rainbolt, who's the fish and wildlife biologist at Fort Drum, and also the project planner and kind of oversees all this from their side of it. Up front, I want to just give a plug for the American Wildlife Conservation Foundation. They're helping put on this webinar tonight, and they are also one of our early funding sources that helped kind of get the ball rolling on our project. They are an incredible organization that has helped fund hundreds of projects in the Northeast. And this has really allowed a lot of different grad students to be able to study different projects that are important for conservation. So our research takes place at Fort Drum, a US Army installation just south of the Canadian border in northern New York. The installation has about 18 to 20,000 residents, depending on the time. It fluctuates a bit depending on deployments and such. It includes both the soldiers, their families, as well as some civilian employees that also live on post. And there's about 2,500 civilian employees that work on Fort Drum. All of our work really focuses on the cantonment area, which is the urban and suburban part of the Fort Drum. This is the areas where you have dense housing areas. It's really like any typical community, though. It has a mall, it has grocery stores, it has gas stations, it has a movie theater, bowling alleys, etc. So you can really think of the cantonment area just like any other typical Northeastern community. It just happens to have a lot of military equipment. Fort Drum is characterized by mostly forests outside of the housing and office areas. However, you'll see here in a lot of these brown areas, particularly on the top portion of the cantonment area where you're having increasing shrubland. Most of that shrubland is from invasive buckthorn, and it's an increasing problem throughout Fort Drum, and I'll talk about a bit of what they're trying to do to deal with that later on. But overall, with all this forest, there's lots of great habitat for deer to move around the area. Fort Drum does have a long-term hunting program with extensive hunting access. The access is in the cantonment area restricted only to the Fort Drum soldiers, their families, and civilian staff are allowed to hunt on post. And then those areas themselves are adjusted annually. What you see in the map, all those orange areas make up the majority of hunting areas that have been available for hunting. However, each year they do reevaluate which areas are open and closed based on programmatic reasons or trying to focus on particular target areas. Fort Drum really is an ideal study site. One of the best benefits about it is it has a single landowner. And so essentially, if we get the permission from the garrison commander to do research, we can go wherever we need to, whenever we need to, which is really, really important in the context of this research, because we can have fawns born any time of the day. We can dart deer right from people's driveways. And sometimes they will fall asleep in people's backyards and such. And in a normal suburban area, you have to get land owner permission for every single site you would go. And that can be very difficult. That also could potentially have barriers if you have certain landowners that do not wish to cooperate. And so for Fort Drum, it really allows us to just study a whole lot about urban ecology that just would be so difficult elsewhere. Before I begin, I want to talk a bit about our role in all of this. So Fort Drum Natural Resources Branch, first and foremost, they set the management goals and objectives for the resources on Fort Drum, and particularly in our case, for deer management. Our role is to independently collect data on the deer herd, analyze the results, and then make recommendations for meeting their set objectives. And then from there, Natural Resources will adapt their deer management based on those recommendations. And then we continue to evaluate the progress and recommend adjustments. Later on, I'll talk a bit about how we are all now working with USDA to help further their management goals. So the original drivers for this project was really first and foremost focused on Lyme disease. And that's because of the fact it was a public health concern for both military families, but in particular, it became a military readiness issue due to the number of soldiers that were contracting Lyme disease. And there were also human safety concerns from the number of deer-related and vehicle collisions. You can see here on the bottom left, that's actually one of our tag deer that was hit by a car about 3 years ago. We regularly do have vehicle collisions. In fact, I had one on Monday night of one of our GPS collared deer. And then here on the right, one of our tag deer with an infestation of ticks. And so with this, the Natural Resources Branch initially teamed up with West Virginia University to start focusing on the tick and small mammal aspect of this management. This comes from the early parts of their work where they found really high rates of the bacteria that causes Lyme disease within the ticks themselves. And when you're having essentially half of all adult ticks being positive for the ability to transmit Lyme disease, and you think of how often people get bitten by ticks, particularly in places where they're in high density, it's really problematic. And so they've continued this work with West Virginia University to this day with several areas focusing on small mammal management. So for us, we're brought in initially to focus really on fawn recruitment and survival. And the reason for that is deer are able to survive, or if deer are able to survive that first year, they can begin to reproduce at really high rates. Does can get pregnant at 6 months and give birth at their 1-year birthday. Starting with their second year, generally they're going to give birth to at least one fawn every year, and often twins and even sometimes triplets and more. And so it's really critical to get at that survival before they're able to actually begin reproducing. So for the Fawn Survival Project, we captured fawns in essentially 3 primary ways. We'd have ground searches where we'd have as many people as possible, including staff and volunteers, search Fort Drum to find fawns while they were bedded. We would also have opportunistic captures if we saw a fawn while driving around or if we got calls about fawns. And then we also would use vaginal implant transmitters to find fawns shortly after they were born. So vaginal implant transmitters are these things here in the bottom. And what we do with them is we implant them in does while they're pregnant. And they have a temperature sensor. And so what happens is you have the internal core temperature of the deer, roughly 98 to 100 degrees Fahrenheit. And when they are about to give birth, it will drop out, and then it can sense that there's been a temperature change. From that, we are alerted that there has been likely a birth, and we can go in and capture fawns. And the big benefits of that is it allows us to capture often the twins and triplets, whereas by the time you would find them ground searching, typically the siblings will have spread out. It also allows us to capture fawns in the middle of the night when ground searching would be impractical. For the ones we would capture opportunistically or from ground searches, we potentially would capture them when they're beyond a few days old. And so for that, we need to know how old they are. So we can use this, which is the hoof growth line on their hoof, along with this equation to be able to estimate how many days old they are, to be able to build them into the staggered entry model. And the reason why that's so critical is that fawn mortality is really weighted heavily towards the beginning of their life. So this shows from our fawn survival period, the first 6 days of their life, essentially, we end up with 18 mortalities before they hit day 7. No mortalities from 7 days to 29 days. And then, so with that, essentially 26% of all fawns captured die within 6 days old. And so if you capture fawns when they're on day 6, day 7, and you add them directly into the model, you're going to be biasing heavily towards those older fawns. For the vits, we would have to capture the adults. And so we'd use 3 primary methods: mobile darting, clover traps, and drop nets. And the clover traps really work just like a kind of a mouse trap, and you can potentially get 2 fawns to go in there and sometimes a doe and a fawn. The drop nets really have the benefit that we can capture multiple deer at once. These are also the methods we would use for tagging deer to be used in the population assessments that I'll talk about in a bit. For the opportunistic captures, we relied heavily on community reporting, and the community reporting that we started off with first in 2015 focused just on fawn capture, but that has really expanded throughout the years to the point where we now rely on it extensively for data collection. And so through our website at fortdrumdeer.org, people can report seeing tagged deer. So you can see here, this one on the left is actually from a hunter just this week who sent me this from his stand. We regularly get contacts from this of our tagged deer. We also have a bulk camera photo submission system where people can submit many photos all at once. And then we also have an online harvest check system where we can get spatial information as deer are harvested. This information is also really critical for our deer when they leave post, because for the ones that don't have GPS or VHF collars, it is the primary way that we actually know where they are. So for all of our fawn captures from 2015 to 2018, this was the predominant way that we would capture them. And the majority of those captures would occur right while the fawns were bedded. Additionally, we did have some where we would net them using custom nets that would allow us to capture them. But the big thing is that we've been very successful at being able to capture fawns on their birthday. And so using all this information, we're also able to figure out the birth distribution. And so this is including all fawns all the way through 2020, because we've continued capturing fawns even outside of the fawn survival work. And what we've seen is effectively the birth distribution is actually seen the same. If we took any of our years, it's actually stayed consistently at May 31st or June 1st, depending on whether there's leap year or not. And from that, you're actually able to essentially backdate when peak rut would be. And rut is when the deer are actually beginning to reproduce in the fall. During that period, bucks will defend the does that they'll be copulating with, so that way other bucks are not able to copulate with those does. And in places like Fort Drum, where you have potentially harsh winters, that creates a strong selection for a very steep birth peak, as you see here. For the actual fawn survival study, we used the 2015 to 2017 birth cohorts, which had 102 fawns included. With that, 58 of the fawns were captured on their birthday. There were 5 fawns that were excluded during those cohorts for various reasons. Most of them were because of the fact that we captured them in the process of dying, and we wouldn't want to bias due to that. And for example, this fawn here on the bottom left is a piebald fawn. The doe had already started abandoning this fawn, and the reason why we found it was because the fawn was calling, and we could actually hear the fawn calling from almost a quarter mile away. And so we wouldn't want to include those fawns because we would never have found them if it weren't for the fact that they were already in the process of dying. So for the survival rate, using that nest survival model that I alluded to earlier, the survival all the way until the beginning of the fall harvest season, effectively the 90-day survival, was about 62%. to 1 year about 50%. And then one of the really beneficial things of having our community reporting system is we have such good accounts of our tag deer even when they leave the area that we've been able to push that on, including all of our fawns out to 2 years, which is very rare for these type projects because typically their fawn collars will fall off between 8 months and 14 months. And so with that, we've had 46% of those fawns surviving to 2 years. To put that in perspective, typically 90-day survival is going to be less than 40%. And the only site that has had published survival data higher than Fort Drum is at the Cleveland Metro Parks, where 78% of their fawns survive to 6 months. In terms of mortalities, the primary causes of mortality have been hunter harvest and predation. I have these broken down here in 2 groups. The group that's in the boxes is all of the human centric modes of mortality. And so you have hunter harvest, vehicle collisions, capture related, and even lawnmower mortalities. And then further on, you have predation, abandonment, hypothermia, and neonatal being natural causes of death. But the reason why this is critical is that 17 out of 18 mortalities after they hit that 90-day point were from hunter harvest or vehicle collisions. So effectively, if they make it past that summer, the only way that they are generally going to die, or at least the overwhelming majority of them, is going to be from human interaction. In terms of the predations, 10 of them have been coyotes, and there was 1 bobcat. And we're able to know that information off of essentially running a forensic scene, collecting data on that, or a lot of measurements on the actual site itself, as well as taking tissue swabs to have genetic analysis. This is one of our coyotes. I photographed this summer on post, and they are quite prevalent. Overall, looking at mortalities from Fort Drum, management related has been the largest cause of mortality, and that's effectively culling, which I'll talk about in a bit, captures and other things related directly to management. But what you can see here is essentially the top 3 causes, which make up more than 80% of mortalities, is just from human related causes of mortality. And that's such a big issue. And you can see here also on the top, in total, with all of this, we've had more than 450 captures, or 450 different deer captured. And so it really has a large data set to be able to look through all of these causes of mortality. The deer have had really high reproductive rates. We've averaged more than 1.6 fawns per doe per year, and more than 20% of doe fawns have been getting pregnant when they're actually fawns. And what's really incredible is we've even had at least 1 case of twins being delivered at 1 year. You can see this photo here on the bottom, the doe with the button tags, and you lightly see it, but she has her fawn collar still on, and those are her twins that she had. So essentially she's getting pregnant at about 7-8 months old, and then giving birth to twins on her first birthday. And so when you have that and you saw such high survival, that's where you really start to see population issues arise. When we first came into Fort Drum Natural Resources Branch really thought that it was a mostly closed population. There is fencing around the entire cantonment area. However, there are several gaps, mostly at the entranceways into Fort Drum, as well as some access points along rivers and access points for rail access as well. And so one of the first things we discovered immediately in 2015 was that it was a very open population. And we've had our fawns dispersed long distances. You can see here in the bottom right corner, doe 65. So she was one of our 2016 fawns, and she was harvested last year about 20 miles away. We've also had seen cases of our deer spending time in and outside the fence. And so on the bottom left, you have buck 643. That shows 1 year of his data, and we've actually seen him repeat this. And for him, he actually seasonally will go and spend his summers out in the farmland along the cornfields outside of post, and then come back in for the fall through early spring. And we also tend to see a lot of dispersal this time of year from bucks. And so on the upper left-hand corner, you have buck 662, and that's actually the last 2 months of his GPS collar data, going from a very small finite range on post to then leaving and actually moving quite rapidly outside of the fence. We've also had our deer kind of dispersed all over the North Country, as I'll talk more in a bit, but the upper right-hand corner shows some of our dispersal. So with all this, once Fort Drum saw that there was a really high fawn survival rate, we all kind of came to the same conclusion that there would likely be potentially overabundance issues. And so Fort Drum wanted to get a grasp of what that might look like. And so we were commissioned to complete a robust population assessment in 2017 using mark resite models. And for the 2017 model, we used 78 cameras with 29% of them being tagged during that assessment. And also with all this, there was clear overabundance issues throughout Fort Drum. And so you'd see overbrowse, as you can see here in the upper right, damage to trees, including the ones that are planted by the landscaping crews. But then in the actual forest, which you typically see is each year, lots and lots of new seedlings that would sprout. But effectively, it was very hard for any of them to actually survive to saplings. We also completed an additional follow-up assessment so the first one in 2017, I found essentially that the deer were above about 45, 48 deer per square mile. And then we had a follow-up assessment completed in 2018 where we saw an increase in the population, as we would expect based on what we knew about the fawn survival rate. And both of these assessments showed that there were clearly clump distributions with some areas having more than 100 deer per square mile. Starting in 2015 and as we moved forward, Fort Drum started to really focus a lot of their forestry work on measuring these deer forest impacts. And so you can see here all of that ground with lots of sapling or seedling cover, but very few surviving saplings. And so they started to set up small exclosures just to monitor changes that particularly could happen as they would begin any kind of management action. And here you can see that after just 1 year, you started to see saplings that were able to survive and actually start to grow up. And we're hitting the 5-year point now. And so they will be actually doing large scale monitoring to see what has changed over these 5 years within each one of those exclosures. At the same time as all this, and actually predating all of our work, Chris Dobony has been working on bat research at Fort Drum going back to the early 2000s. This work became much more important after the discovery of white nose syndrome in 2006. And white nose syndrome, as many of you will be aware, is caused by fungus that has decimated bat populations all over North America, but was initially introduced in New York, likely from spelunkers coming from Europe. And with that, Fort Drum was one of the first sites that actually had cases of white nose syndrome. And so Chris has been working on all this work for many, many years, focusing on their conservation. But Chris really wanted to kind of focus on the best ways of being able to manage and conserve them. And so some of their first work started to look at what were the critical seasons for them, when it was important for the survival of their pups to be able to survive, as well as where the important roosts were on posts. And then also getting into more of their ecology, what were the most important sites for them to forage to be able to help with their survival. And so what they found was that the proximity of 2 riparian areas along forest edges, essentially the areas that were closest to a forest edge and water access were the most critical for them to be able to hunt as they needed. And so with all of his work, they established bat conservation areas, which you can see here on the right with all the checkered areas. So all the checkered areas around Post were areas that were found to be critical for bats for roosting habitat as well as for hunting habitat. And this was very well studied using VHF transmitters. They would actually go out and track the bats in flight to be able to find where the bats spent most of their time. But what also you see here on the right is the distribution from our 2017 deer population assessment. And what we found was that the highest deer densities were almost all overlapping exactly with the bat conservation areas. And in fact, they essentially were choosing for the exact same habitat. And the reason why this kind of shifted all of our work is because of the fact that Fort Drum, being a federal entity, has to manage for endangered species in perpetuity. So they can't worry about just where the forests that are being conserved are today. They have to manage for those forests where they'll be in 50, 100 years down the line, because they need to conserve all this bat habitat for these endangered species. And so that really shifted our focus from being human health focused to being conservation oriented to help conserve these critical bat habitats. One of the other things that's a big problem in terms of those conservation areas is that while the most number of deer are usually harvested in these northern areas up here, the issue essentially became that when you actually look at the harvest pressure on these areas, most of the bat conservation areas actually had the lowest amount of hunting pressure when you actually looked at it, the number of deer over the actual size of the area. And so essentially there isn't enough deer actually being harvested in those areas to be able to see any kind of reduction in deer density. So kind of bring this all together, the fawn survival rate was too high, the reproductive rate was too high, and the population was too high. And so with all this, it really became a requirement for Fort Drum to start pursuing drastic reduction in deer density. And so in 2017, we had our first round of recommendations, and the big overarching themes were essentially Fort Drum needed to increase hunting pressure. They needed to, these are potential management actions. They didn't need to do any individual, but the potential options would be to increase hunting pressure, to use mobile sharpshooting to be able to increase take, to have baited shooting, again, to be able to help with removal. They could do habitat modification to both focus on specific bat habitat, as well as to be able to assist with any kind of the culling activity. And then for the most critical forests, for the areas that are really important for them to save, they could look into exclosure fencing in those areas, as well as if they could potentially increase closure of the external cantonment fence, that would have helped them close the population a little bit more to potential immigrants from throughout the area. So with this, I'm going to first go through what they went for with expanded hunting. This was the area that there was the most hope for because hunting is definitely the preferred option. It's the most socially acceptable part. It's acceptable to the existing hunting population. And this also is just the least resource intensive. And so the hope was that if they expanded hunting access, that could make a significant impact. And so in 2018, they expanded the available hunting area by more than 35%. They added ground blind hunting, whereas they historically only had tree stand hunting for safety reasons. They instituted an earner buck program to increase doe harvest, where you had to harvest a doe or an antlerless deer before you could use your buck tag on post. They worked with New York DEC to get enough DMAP permits, which are management permits that allow for antlerless take to assist landowners being able to reduce deer densities. With that, they were able to get enough DMAP permits where every hunter effectively would always have one with them, and so it would allow an unlimited take of antlerless deer. And then they added a lottery for small hunting areas that would normally be closed because they'd be too small for safety reasons to allow multiple hunters. In 2019, due to culling that had began, as well as some pushback from within the community. They removed the earn-a-buck requirement, and they added shotgun hunting to allow additional hunters to take, as well as efficiency. And then in 2020, they really started to focus on the areas that had high deer density. So they closed areas that had historically been open to hunters that would have lower deer densities. And oftentimes you'd have hunters spending significant amount of time in areas where they'd have low probability of success. And then they've also added semi-permanent box stands that are predominantly going to be used by USDA-Wildlife Services, but for access for hunters as well. And so with all of this, they did see an increase from 2017 to 2018. They saw an increase. However, it's really hard to judge with this if the increase was related to increased access, or if it really was just related to the population still increasing, because that had been the general trend for quite a while at that point. Starting in 2019, you saw a big drop off. And in 2020 so far, we're on track for likely being an increased reduction over where it was last year, or potentially coming right around even. And likely all of this is related to the fact that deer have changed their behavior. As I'll talk about in a bit, the population likely is pretty similar, but a lot of this is both from the changes in deer patterns, as well as some hunters have been frustrated by some of the other management actions. And so we have seen lower hunter involvement on that end. So moving on to the sharpshooting, this was all done with USDA-Wildlife Services. And so this is when we started to kind of all work together, where Fort Drum would be the liaison with USDA. And they actually hired their own staff member from USDA who would help with other wildlife service issues throughout the year, or wildlife damage issues. And then we assist them by collecting data, monitoring their program, as well as providing information to help them improve their culling activities. In the first year, from 2018 to 2019, they did 9 nights of culling. And in those 9 nights, they had 253 deer culled, including 163 does. This last year, the 2019 to 2020 season, again, they repeated 9 nights. But the big change was that the first year, they did 4 of those nights in September, and the rest are in the winter. This last year, all of them were during the winter to help the use of bait. And this last year, 95 deer were culled during this program. It's important to note that all of the deer that is culled by Wildlife Services is donated, and they're donated to 50% to the Food Bank of Central New York, and 50% to a program called Feeding Our Vets, which helps retired vets throughout the North Country. And all this together, just as an FYI, they've already donated almost 20,000 pounds of venison through this program. In terms of the baited shooting, this really became a focus this last year. So 56 of the 95 deer that were culled in the 2019 to 2020 season were shot on bait. 20 of those from normal tent blinds on the ground. This year, they've added 12 semi-permanent box stands that will be used intensively throughout post, particularly in areas that have historically not had much hunting or culling pressure. But with all this work, the big question is, where are they likely to be? And so what you see here is the 2 different assessments, the 2017 and 2018 assessments as to where the population was, and then including all the information that we know. So fawn survival, adult survival, and we were projecting out effectively where the population would be. And so we could get this through 2019 quite effectively. We left the projections after fall 2019 because we did a much larger population assessment this spring in April and May 2020. That will be our largest assessment to this point. It'll also likely be our last large-scale assessment as part of this research. The one thing to note here is that this does this projection of an increasing population including the culling and removal, likely is inflated a little bit due to an inflated buck survival. And that's because of the fact that we historically didn't have much data on bucks as they got older. From literature, it's very clear that bucks generally have lower survival due to the stresses of rut, as well as just behavioral differences between bucks and does. However, because we didn't have the data, we couldn't make those broad assumptions. To put that in perspective, in the GPS collar study I'll talk about in a bit, we captured effectively the same number of bucks and does, 48 and 49, but during the last year and a half, we've only had 5 does die of non-harvest related mortalities, whereas 15 of the bucks have died from non-harvest related mortalities. And it's actually skewed even more because with each of those bucks, we would then redeploy the collars. And so many of those captures are even more recent. And so overall, you're looking at a much lower buck survival compared to doe survival. And so that would likely lower the projected population by a bit. So for this assessment that I talked about for 2020, we expanded up to 220 cameras. And we also did this assessment after all of the culling. So we'll get a true minimum population for the 2020 year before fawns were born in May and June. We're almost done with this assessment, and the early results indicate that the population likely stabilized since the 2017, 2018 assessments. It's probably going to be down a little bit from the 2018 assessment. Even with all of that work, though, with the 350 deer culled, the increased hunting pressure, and all of that work, and effectively they're just getting back to where they were probably in 2017, maybe a slight reduction. But one of the problems here is really about how the deer are distributed. So once again, you have the distribution here on the left, and then on the right, you can see where the deer were actually culled. And one of the problems with most culling methods is that you really need good road access for both sharpshooting as well as if you're doing baited shooting, because of the fact you need to be able to regularly drop off bait. And what we essentially see is that the deer that are being taken are almost exclusively on the fringes of the deer populations. And so while they're able to take a lot of deer, what we've seen over the last 2 years, where we went from the 250 the first year to about 90 the second year, is likely because they've been able to remove those deer on the fringes or pressure the deer that normally would live along those roadsides to spend more of their time further into the woodlots. And so this is a common problem that is seen in many culling projects. And so that leads us to the next aspect of our project, which was to focus more on what's happening with the deer. How is their movement changing? And so we deployed about 70 collars over the last 2 years to look at how the deer are adapting to that increased pressure, because it is a very common thing in many culling programs where it's really easy to get that first 50% of the deer or 30% of the deer, and the next 50% becomes harder, and the next 50% becomes harder. And so you end up with this problem where as you're getting down to the last portion of the deer, it really becomes very difficult to be able to get those deer that have adapted well. And so the idea is to start monitoring deer for those movements. And so we'd have these orange collared deer that could not be shot, and they would act as sentinels, so we could actually see how the deer within the population could actually, or were actually reacting. And the proof of concept for this was completed by a few interns of mine last year. And so what they were able to find was that the collars themselves could act as a predictive method as to when the deer would actually be along roadsides or available for culling. And with this, the idea is I can hand over the data to USDA as the season progresses as to when the deer are going to be most active and how that changes over time. And then we can also monitor how the deer change in their distribution. Does their home ranges change in size? Do they spend more of their time in certain areas? Are the places where they feel more safe? All those type of things we're able to now answer with these GPS collars. And then the idea is to also expand this out and look at some of the issues like the migratory deer I talked about that spend part of their year inside of post and part of the year outside of post. And the reason why that's really critical is if you have deer that are only going to be in for certain periods of time or only in certain areas for certain area of time, if you're not able, or if you're not doing culling during those periods, or you don't have access to those deer at those times, then you're not going to be able to actually see a reduction in the population for those deer that have that behavior. And lastly, we wanted to really see what happens around bait, because historically lots of culling projects have seen that that deer on bait will slowly over time start to really change their behavior. And so that's part of what we want to see, even if it's just the time period that they're on it, but also if they happen to be on a bait pile and there are other deer that are shot. Typically on these bait piles, you may have 7 to 10 deer that may be on the pile. And so it's very rare that you'd actually be able to take out every deer at once on the pile. If the deer that were also there when the other deer were shot, what happens to them? How long does it take before they get comfortable to actually come back to the bait? All of those type things are some of the questions we're trying to answer with these collars. Moving on to habitat modification, this was an area that Fort Drum really started to invest significant amount of resources in this year. And this really is the culmination of several different parts of the natural resources branch. Part of this is really focused on deer removal. There are areas that are specifically having buckthorn removal to open up shooting lanes to help wildlife services with culling. Part of this is from the bat conservation area. So the idea is that you'd be able to actually grow some additional forest beyond the current extent of the BCAs, where the future forests could be regenerated as well as potentially planted. And then part of this is also getting from a forestry aspect of trying to improve forest ecology. There are several foresters at Fort Drum where that's their primary focus. And so they started this where they would go out in these areas and essentially take down absolutely everything that wasn't a native tree or tree of focus, and then they would continue grinding it down. So you can see here on the right, as they started in the spring, and then here on the left is one of the areas here from this fall. I'll show you some more here in a bit. But there are extensive areas that they're trying to do this with within just actually one region of the cantonment area. And so some of these areas is focused really on culling. Some of these is really focused more for forest management. The areas that are filled in red, those are the areas that have been already cut down at this point. But to put this in perspective, they had several crews working for quite a few weeks, and they're only able to get through those red areas. And then each one of those then have to be followed up with continued cutting throughout the summer and fall. So that way they can stop any new invasives from growing. And so if they want to get to these goals long-term for all three of their priority areas, it's going to be a very long-term and resource-intensive program. And you can see here more of their areas, and it's just going to be a long-term project. Some of these areas, effectively, there was nothing left. And so you see here on the left, this is one of our areas that actually sort of is the bane of my existence over the time doing deer capture, because the deer would all run in right from the road. I would catch them all the way up by the road on the right side, dart them at 20, 30 yards, and then they would go into this buckthorn. And it was so thick that you would literally have to crawl on your hands and knees to get through it. And so those areas, it became essentially a monoculture of nothing but buckthorn, and those entire areas are going to have to be reforested or converted to prairie along the way. Here on the right was a forest where they were able to conserve some of it, but what you really can see here is that all these areas really got inundated with buckthorn. So the trees that were left were really kind of the unhealthy ones that were able to kind of put up with the buckthorn. And there are some forests that in the areas that are cut where almost all of the actual canopy has died and didn't make it through because of just the amount of pressure from all the buckthorn. They are actually doing some plantings as well. And so this year they started just mostly a test to see if they could get American chestnuts to take. And so they had 34 American chestnuts planted, and all of them are being very closely protected in these plastic tubes. And those will be being monitored over time. And potentially shagbark hickory will be planted additionally next year, as that's a species of focus for several of the foresters. There are a lot of things that they're still working on, but from our original recommendations, one of the areas where they really got to continue to work is on population closure. But this is going to be very difficult. The gates themselves are hard to actually reduce because you have to have gate access for the lots of people who live on and work on post. and even in the areas where you have the most restricted gates. And so this one here on the right, this buck actually went in and out two of the smallest gates on post. Even in those areas where they have to go right through heavy traffic, they are able to actually move and disperse from those areas. And then deer exclosures is of critical forest is an area where they're having continued focus. They actually initially planned to actually start building a large deer exclosure this fall. And these exclosures are going to be quite large. So whereas the current ones they have are really focused on monitoring, some of these exclosures that they're looking at get into the several acre range. And they're going to be focused on really trying to regrow and foster healthy forests in absence of deer. This year, we started to really dive into our genetic research. And so throughout all of our work, all of these captures, all this harvesting and culling, we've actually been taking tissue samples for all these years and actually have more than 900 tissue samples in our tissue bank. And what we're really trying to do is to understand more, what are the barriers to movement within Fort Drum, how much the large roads impact their movement. This is a big issue in a lot of suburban areas. If we start doing lots of culling, if there's lots of focus in some areas, is that going to stop them from moving to other areas? And a lot of that we'll be able to understand more using genetic analysis. But even more importantly, we want to understand what's going on in terms of the entire North Country. What are the barriers to act them? How much does the fence act as a barrier, as well as the interstates and things that are around the North Country? And this is going to be a plug for anyone who's listening who happens to hunt in the North Country. If you hunt anywhere within about 50 to 100 miles from Fort Drum, I would encourage you to drop off or mail in a tissue sample. All the information is on fortdrumdeer.org. Also, if you know anyone who hunts in the North Country, I would also encourage you because we really need a lot to gain samples from outside of Fort Drum. And the reason for that is that this study has really become a regional study. We've had many deer dispersed beyond 20, 30 miles from Fort Drum, including this buck here in the bottom right-hand corner. That's buck 18, who was captured in 2015 as a newborn and was harvested in 2018, 3 years later, in Kingston, Ontario. And we've also even had deer go all the way out to 116 miles from Fort Drum. And this is actually a doe that went the 116 miles. And so we now know that our deer really are spending a significant amount of time throughout the North Country, which likely means that there's a significant movement of the gene pool in and around the region. And we're really trying to understand how much the different kind of barriers like the fence actually have on the population. So with that, all this work would not be possible without all of our funding and research partners who have made really all this possible all these years. And we also have had an incredible team at Fort Drum, all of our team at Cornell, my graduate committee, the biologists at Wildlife Services who work with us on being able to actually interpret a lot of our data, and then also our incredible field staff, interns, and volunteers. And in particular, I want to give a shout out to all of the volunteers and family members from Fort Drum who've spent lots of time, and hunters who've put up with all of our crazy antics all these years. You can see here on the bottom right, some of the soldiers who've even chipped in and helped. If you are interested in more information, I really encourage you to check out fortdrumdeer.org. That has all of our information on our tissue collection, as well as on other aspects of our research I didn't cover here today. We have a large social media presence, particularly through our Facebook page, where we communicate regularly with the public. But also, if you're interested in the project and frankly, wildlife photos in general, you can check out my professional Instagram here on the left, but also here on the right, I just want to highlight our Instagram at Fort Drum Deer, which is a page that we've just set up as we've been going through the 2020 trail camera assessment. We wanted to be able to create a level of transparency for hunters on post because we've often had questions with all of our camera assessments, especially when you have 220 cameras on post. People run into them regularly, and hunters want to also know, how we actually come up with these numbers. And so for every one of our cameras, we go through and actually take some of the best photos from each one of the cameras and share them. But that way, the hunters can actually see how we use all of the tagged deer information to be able to make the assessments that we do. And with that, if there are any questions, I'll start going through the chat right now.
Great job, Martin. There are some questions, so if you handled them well at lunch, if you want me to help anyway, let me know, but I'll just let you go to it if you want.
So it looks like the first, let me just make sure there are any higher ones.
There's one at 708.
Yep. So it looks like the first question is, have they tested for other tick-borne diseases, and what is the percentage of twins and triplets? So in terms of the tick-borne diseases, we don't look at the deer specifically for that. Pretty much you'd expect near all of the deer to be able to actually have presence of the bacteria, but it's not really much of an issue in terms of the deer themselves. So that's not something we would focus on. In terms of the twins and triplets, essentially almost all of our does, from the time that they hit their second year until about 7 or 8 years old, almost all of those years they will have twins. We do start to see some reproductive succession as the does get older, and so we'll start to see them go down to only 1 fawn per year. And then we do have some does that have been in the study for a very long time and were very old when we initially captured them, and we're starting to see some of them that are like effectively in their teens stop reproducing. And a lot of that might just be in terms of the fact that resource-wise, they may not be able to actually be able to handle reproducing. For fawns, for the doe fawns, almost all of them that have gotten pregnant only have 1 fawn, with the exception of the one that I highlighted. And then for yearling does, it's about 75% of the yearling does give birth to 1 fawn, and then the rest, about 25 or so percent, will give birth to twins. And for triplets, for the Fawn Survival Project, we were having 1 to 2 sets of triplets per year out of about 25 fawn. Well, so it'd be essentially about one out of every 15, 20 does in a given year we're having triplets. Okay, so what is the target goal on Fort Drum for deer per square mile? While 100 per square mile is quite high, in my area in Vermont, our goal is to try to get to no more than 18 deer per square mile. We are above that in the 20s to 30s per square mile, but we still cannot get adequate regeneration at those numbers. Yes, so the goal for Fort Drum for the cantonment area is to get below 15 deer per square mile. That is the goal. As you can see, it's going to be probably a long time for them to get there. They're going to have to dramatically increase their resources. The other thing is, as you get to a certain level, so you're talking in Vermont at the 20 to 30 deer per square mile, as you start dropping below that, part of the problem really becomes that you essentially lose hunter activity, because once you get below a certain point, there's less of an incentive to actually hunt. There are areas in the country where there's more of a historic relationship with hunting. So like in the Adirondacks, there are places that get down below 15 deer per square mile naturally, but there's more of a historic relationship with hunting at those low densities. And so hunters are more cooperative with that. But that's one of the issues, is effectively if Fort Drum's going to get where they're going to go, eventually they're probably not going to have hunter activity as part of the pressure on the population. Can Fort Drum use prescribed burning on the property? So they do use prescribed burning, particularly in the training area. And so they do have a team that does that. In the cantonment area, that's just not done as much. And frankly, it's quite wet, so it'd be difficult in areas, and there's not as much prairie land. In terms of like dealing with the shrub, that just becomes such a concern because it's so close to people's homes. And all the offices, but it is extensively used downrange in the training area. They do extensive burning down there, and they also have support from the Fort Drum Fire Department that help support that as well. Where do tissue samples go again? So all of that information go to fortdrumdeer.org. And on there, we have the different methods that you can submit, because they can be mailed in. They can also be submitted at one of our check stations where we have vials of alcohol, and they can be submitted in those. It has all the information for what we need for the information on the harvest, where it was shot, all that stuff. And then in terms of how we use that, that's all going to be used for looking at how the deer actually distribute across the North Country, and how barriers like the fencing on post and the interstates, and even the Adirondacks, how all of that starts to limit gene flow throughout the North Country. Which tree species are particularly desirable for bats? So the big thing on post is that it comes down to they need mature forest, and they need mature forest that is adjacent to the edges and the riparian areas they need for hunting. And so most of the forests that kind of meet those descriptions on post are maple forests, so sugar maple and red maple in particular. They also some like hophorn beam, and black cherries is another one that's pretty common there. But the maple stands just are the dominant species in the areas that kind of meet all the other ecological requirements for the bats. Is there any fawn euthanized? Not sure what you mean by that. If you mean that if we've ever had a fawn euthanized from fawn capture, we had one fawn that did die in the process of capturing because it was an older fawn that we captured in a net. That was the only one that we had any kind of issue in terms of that. But we've never had to euthanize any fawn from the actual fawn survival project. We have had to euthanize some deer that have been captured for like the tagging and our other research, the collars and other things as well, because there are some accidents that happen, and we want to make sure that we put the deer's suffering into importance. So if we have a case where a deer was injured in the process of capture severely to the point where they wouldn't be able to recover, as part of our animal care protocol that's approved by veterinarians, we will euthanize in those cases. Would it be more beneficial for the threatened bat populations if the exclosure was built in that riparian forest habitat as opposed to open woodlot? So for the most part, the exclosures won't really impact the bats because the exclosures aren't going to be high enough. And so that's not actually going to be much of an issue. The other thing is that the exclosures themselves are going to be just covering the woodlots themselves. None of the proposed exclosures are actually going to be crossing any of the riparian areas. And so the idea with exclosures mostly is really to encourage growth in the areas of forests that are kind of the best habitat right now, or the areas where they would most like to see new growth to potentially expand those conservation areas. So that's kind of the idea with the exclosures, is either really focusing on really high quality forest that's there now that they want to protect, or potentially new areas that they could expand. Any other questions? Do you have any deer sterilization plans? So for Fort Drum, they have not really focused on doing any kind of deer sterilization. And the primary reason for that is that when sterilization is typically used, it's when there's going to be more of a social construct issue where you have landowners who are going to be uncomfortable with it, where you have local community, because sterilization itself is much more resource intensive than all of this already is. And it also, you have a long lag time. So if you sterilize them now, then you have a long lag time before you actually start to see a reduction in population, because effectively the deer can survive, long periods of time, and then they're continuing to do the damage all the way through that. And also the amount of resources that would go into sterilizing them when the deer's still going to be there versus if they put the equal amount of resources would allow them to actually cull many more deer. It's just not an efficient case. And so with it being a federal property and with it being the fact that this is endangered species management, they have to manage for this. This is important for conservation, and they also have a federal requirement to do this. Sterilization just wouldn't meet all of those contexts for post. In the Tug Hill, where my NRCS working lands for wildlife project grant funding work took place and data studies continue on our 10-year study area, it was shagbark hickory and mature red maple for both long-eared and Indiana bat habitat. Dramatic results, yep. And that's what we've definitely seen is the maples on post are really critical for them. And the shagbark hickory, that's why that's potentially where they'll be expanding into plantings for next year. So that's great to hear that. But yeah, that's definitely very critical for Fort Drum. Any other questions?
Martin, you did a great job. Again, I want to thank you for all the effort you put into this. It was engaging and well delivered and scientifically rich and robust. So it's like hit the high points of everything. So thanks very much for that. Thank you all for participating. And I hope everybody has a wonderful Thanksgiving. See you in December.
Thank you.
Thank you. Take care.
Everyone.